Hello, my name is Charles Hamill, and I will be doing a demonstration for you today. Just so you know, I'm an undergraduate. I do not believe I did anything extra. I just kind of did a min-max algorithm and stuff of that sort, no pruning methods. So, the first comes first, and we'll show you the item. So it's console-based. As you can notice, that you activate the jar and you hit a file, and if it's in the right format, it'll run the code. And as you can see, it runs through. So test case 3, test case 2, and test case 1. So let's get to the code. So within our main, you can see we have a couple flag argument checkers. And we essentially something called a move controller. And this is kind of like the main runner. This is kind of the main controller of the controllers. And we instantiate that controller using that test case for these files that start this input files. And as we do, and the main just iterates across, asking for the next move until we hit null, and we just see the user win. So let's see. First things first, let's get what the node is. So what node consists of is node holds all items. It holds the parent, the next set of moves, and holds the max depth value move in the map. So each node stores the current available amount of moves, the moves that node represents, and then it also holds this constant max depth to ensure that it doesn't go past any constraints, or past a certain number of depths, so it's easier to control. And there's not much to it. We have a constructor for the root node with a depth of 0. We have the middle node, which increases the depth based on its parent. We have the evaluation. And we evaluate each node based on the number of items with the number of combinations for those numbers that have already occurred. So we have our main, which we're going to a move controller. Control does several things, such as instantiating the map based on the size to make n squared. The map we actually instantiated to be a hash map of array of integers. And it's not that the position of the integers of the index represents the integer, but the value within that index, which allows us to save time by, instead of processing 10 elements to figure out which one has not been erased, we have 4 elements which are available moves. Okay, so again, we have the parse moves, we have the make move, which removes the move off the stack, and then we have get next move, which we call our search algorithm, passing the map in the last move, and then we ask for the best move. So within here, we pass it, we create a root node, and what we do is we search the tree. So within this tree, we're going through and we're building it. And every time we build the next set of nodes, we set that node to visited to equal true, and then we keep going until we hit a leaf. And we're going to hit a leaf at some point. The node's going to self-build the next set until they hit a max depth of 2 or a leaf. And what happens is we then begin to move back up the tree, searching for visited true. So once all the leaves are evaluated, we check for parent, and so then we take some time here. So we walk in, and for every node that is in a leaf, we keep evaluating, looking for children, adding those children to the stack, and keep moving down until we either A, hit the max depth, or we just hit, and then there's no children left. Since the visit equals true, we end up actually moving. We end up re-putting the parents back on them once all the children are evaluated, and we then evaluate. Then we can look at the parent children, check for that value based on that depth. So like if it's I can actually show you the comparison. So within the compare, we check the depth. If the depth is even, it's max's turn. So then we have to reverse which it. So if value 1 is greater than value 2, we return 1. If it's min turn, if value 1 is greater than 2, we actually return -1. Which allows me to do these inverses. And then from that, we iterate over those list of nodes until we find one that's the best for max, or for that node, whether it be max or min. And yeah, that's kind of just it. After that, we return it back to the main controller, which then makes sure that if it's null, which then updates the master record, returns the new one, or it returns null, which then the battle just ends it. Thank you for your time, and